The given functions represent the position of a particle traveling along a horizontal line. So we have a position function s of t equals t divided by 1 plus t squared. Then, first of all, we want to find the velocity and the acceleration functions. Okay, well, velocity is, of course, the first derivative of the position function, so we'll find the velocity function through the differentiation process. And then the acceleration function is defined as the first derivative of velocity, so we'll find the derivative once again. Next, we need to determine the time intervals when the object is slowing down or speeding up, assuming t is greater than 0. And there's a hint here saying that the particle is not necessarily speeding up just because its acceleration is positive. So what's happening here is an object is speeding up whenever the sign of the velocity and the acceleration functions are the same. So it's speeding up when the velocity is greater than 0 and the acceleration is greater than 0. All right, and another case is when the velocity happens to be less than 0, but the acceleration is also less than 0. So in both cases, the object is speeding up. And so you can sort of think about this with like ballistic motion. So if you have an object thrown off the top of a tower, it's going to eventually fall back down to ground level. And what forces it back down to ground level is the acceleration due to gravity. And the acceleration is negative. So the reason that the object speeds up toward the ground is because both the velocity is pointed downward and the acceleration is negative as well. So it speeds up toward the ground. So that's one thing we have to take into consideration. The other consideration is when we are slowing down, velocity and acceleration have opposite signs. So the velocity would be possibly greater than 0, and the acceleration would be less than 0. Or the velocity is less than 0, and the acceleration happens to be greater than 0. Okay, first thing, we need to find some derivatives. So let's begin there. So I'm going to take my position function, which is s of t equals t over 1 plus t squared. Double check that. Okay. Now, the velocity is, of course, going to be the first derivative. And if you take my classes, you'll know that I do a derivative of a quotient using kind of a box off to the side. I put my numerator and denominator in these two parts of the box, and then the derivatives of each of those in down below. And as long as I remember to multiply these two corners together first, it just ensures that you get the direction of the sign correct in the quotient rule. So anyway, the velocity function here would be 1 times 1 plus t squared minus 2t times t, so that would be 2t squared, all over the original denominator squared. So it looks like then I have a velocity function which is going to be 1 minus t squared all over 1 plus t squared, quantity squared. Okay, so then the next thing that I need to do is find the acceleration function. So the acceleration function, as I mentioned, is the first derivative of velocity. Well, my velocity function is also a quotient, so I'll use my quotient rule again. So 1 plus t squared here, and the denominator 1 plus t squared, quantity squared here. The derivative of 1 plus t squared is just 2t, but this next derivative I need to use the chain rule, so I'll bring the 2 down, do 1 plus t squared to the first power, and then times the derivative of the inside part, which would be 2t. And let me make that look more like a t there. Okay. So the acceleration function then is going to be the product of these two items. So that's 2t times 1 plus t squared quantity squared minus the product of the remaining two boxes. So this would be, let's see, 2 times 2t. So I'm going to write that as 4t times, are these both 1 plus t squareds? Because that's nice. That's just going to be, oh, no, it looks like I made a mistake. So the numerator was actually 1 minus t squared, which actually changed that sign. So this is a negative. Okay. Then let's see, do I have the rest right? So minus 4t, and then it's 1 plus t squared times 1 minus t squared. All right, and then all of that is over the original denominator, which was 1 plus t squared, quantity squared, and it's now going to be 1 plus t squared cubed. Okay. So looking at this, I can see in the numerator there's some common factors. So clearly I have a negative 2t as a common factor I could pull out. But it also, oh, sorry, that's to the fourth. There's also a common factor of 1 plus t squared. All right, so from this term right here, if I pull out negative 2t times 1 plus t squared, that's going to leave me with just 1 plus t squared. All right, because the negative 2t comes out, and then there's two factors of the 1 plus t squared. All right, now looking at this term over here. If I pull out negative 2t, that's going to change that to a positive 2 on the outside and leave me with 1 minus t squared there. All right, all of this is still over 1 plus t squared to the fourth. And the nice thing about this is I can see now there's a factor of 1 plus t squared shared with one of these, so reducing that down to the third power. And looks like I can do some more simplification in the numerator. So this would be 1 plus t squared. Then this 2 is going to distribute into these parentheses. And that's going to be plus 2 minus 2t squared all over 1 plus t squared to the third. I think I have just one more step in simplification. 1 and 2 will combine to 3. T squared and minus 2t squared would be negative t squared all over 1 plus t squared to the third. Okay, so to wrap up, I've now got my derivatives. So here's my acceleration function. Let me just kind of highlight that. And up above, I have my velocity function. So that's this one right here. Okay, now, what I want to do from here, since I now know the acceleration and velocity functions, I need to know where these functions are positive and where they're negative so that I can determine where these things, where this object is increasing in speed and where it's decreasing in speed. So to do that, the first thing is to find out where it's 0. It's much easier to find out where something is 0 than anything else. So let's try and determine first where the velocity function is equal to 0. So the next part here, where is the velocity function equal to 0? So I'm going to take my velocity function, which was 1 minus t squared all over 1 plus t squared, quantity squared. And let me just double check that real quick. Yep, looks good. And let's see. The first thing I notice here, this thing right here, this denominator, if I put anything in for t, it's immediately squared. So if I put a negative number in for t, it gets squared. It becomes positive. If I add 1 to a positive number, that's positive. And then if I square it again, it's still positive. So the denominator here is always positive. That's kind of an interesting thing because knowing that, it sort of makes things easier. All right. Secondly, in solving this equation, really my first step would be to multiply both sides by the denominator. If I do that, the denominator just kind of disappears. So really, I only am concerned where the numerator happens to be 0. All right, so difference of squares, I can factor this into 1 minus t times 1 plus t. So that gives me the solutions t equals 1 and t equals negative 1. So there's 2 places where the velocity is equal to 0. And I know that t can't be negative. That was already told to me. But just leaving it in for the time being, negative 1 here, positive 1 there. If I want to know where this thing is positive or negative, I need to test some intervals. So I need to choose some test values between these intervals. So like perhaps -2, 0, and +2, and plug those into the velocity function. So I need to evaluate v of -2, v of 0, and v of +2. Now, I'm only really concerned where it's positive or negative, so all I'm going to do is plug into the numerator, because again, the denominator is always positive, so it's not going to have any effect on the positive or negative end result of the function. So actually, I'll even plug it into this form right here. So let's see. So this would be, well, you know what? It's probably easier even right here. So let's just do that. 1 minus, if I plug in -2 for t and then square it, that's going to be 4. So that's -3. If I plug in 0, it's 1 minus 0, which is 1. 1 minus, and then for 2, that's also going to be 4, so that's going to be -3 again. So on this interval, everything's negative, it's positive, and negative. Okay, so we know what's happening then with velocity. Let's look at acceleration. So when is the acceleration equal to 0? And again, ultimately, I want to know what happens. I want to know when it's bigger than 0 and when it's smaller than 0, but it's easier to first figure out when it's equal to 0 and then get the other points from there. So if I take this function, which was -2t times 3 minus t squared all over 1 plus t squared to the 3rd power. And I'll just double check that again. All right, I think that's correct. Okay, now if we look at the denominator, again, we're in this situation where no matter what, that is always positive. And again, that's just going to make our lives easier in determining which intervals are positive, which ones are negative. So that's a great thing to have. And likewise, if I want to know where this is equal to 0, my first step is to multiply both sides by that denominator. It just disappears. And I'm really only interested then in where the numerator is 0. Okay, so let's see here. I can factor this using the difference of squares again. Even though 3 is not a perfect square, I would just write it like 3 minus t, or sorry, root 3 minus t times root 3 plus t. So then that tells me that t is could be 0, t could be positive root 3, or t could be the negative square root of 3. So those are the solutions to this particular equation. Now, I should also check to see where asymptotes could occur, because your function could change from positive or negative at an asymptote. But again, if this thing's always positive, it's never 0. And so there's no denominator points where you would get an asymptote. So that's why I'm saying knowing that the denominator is always positive really kind of makes things a lot easier. So let's see. For acceleration, we have the points negative root 3, 0, and positive root 3. And if I want to know where this is bigger than 0 or smaller than 0, I need to pick some test values and just plug in and see what's going on. So root 3 is like 1.7, so I could use, say, like -2, then I could use -1 on this interval, 1, and possibly 2. So I need to find the acceleration at -2, the acceleration at -1, the acceleration at 1, and the acceleration at 2. And I only need to use this function enough to determine if the answer is positive or negative. I don't actually need the end value. So, like, for instance, this form right here. All right, if I multiply by, let's say, -2, plug in t, which is -2, and then I would have like root 3 plus 2 and root 3 minus 2. Okay, so a negative times a negative, that results in a positive. Root 3 plus 2 is a positive. Root 3 minus 2, so that would be like 1.7 minus 2, that would be a negative. So like I said, I only need to know enough to know if it's positive or negative on that interval, and so it should be negative. All right, moving on to the next value of -1. Let's see, that would be -2 times -1, root 3 plus 1, root 3 minus 1. All right, so negative times negative is a positive. Root 3 plus 1 is a positive. Root 3 minus 1, that's also going to be positive. So everything's positive on that interval. Then at 1, it's -2 times 1 times root 3 minus 1 times root 3 plus 1. So that's going to be a negative times root 3 minus 1 is a positive. Root 3 plus 1 is a positive. So then everything on this interval is negative. And then lastly, -2 times 2 root 3 minus 2 root 3 plus 2. So that's negative times positive. So everything on this interval is positive. Okay, so these two number lines tell me everything that I need to know. I'm gonna join them together kind of down below here. So one thing I'm also going to note is the domain is only valid for where t is greater than 0. So you know what? I'm just going to start ignoring those values. I'm only going to look at, say, the velocity function starting with t equals 0 and then going to infinity. All right, so we had a point at 1 that was important, and then that was it, okay? Between 0 and 1, we're positive, so the velocity is positive, and then it's negative. So positive and negative. Then the acceleration function, so it had 0 and then root 3. So root 3 is a little bit bigger than 1. Okay, and between 0 and root 3, the acceleration is negative, and then it's positive. Okay, and tell you what, I'm going to split this up into multiple intervals here. So I'm going to make this its own interval, and I'm going to make this its own interval. Okay, so it would be negative on both of those intervals there for the velocity, and both intervals here would be negative for acceleration. This way I can just kind of see what's happening. So the signs are different on this interval. And when the signs are different, as I mentioned early on here, that means that you're slowing down. If the signs are the same, that means you're speeding up. And here the signs are different, so we're slowing down again. All right, so what that tells me is that I am slowing down on the intervals from 0 and, I think I'll just leave it as a open parentheses there. 0 to 1. And then I'm slowing down again, starting at root 3 and going off to infinity. And then I'm speeding up on the interval from 1 to the square root of 3. And that solves it.